Okay, so hello everyone. My name is Isabelle Kuhlmann, and today I'm going to present some joint work with Tjitze, Rienstra, Lars, Bengel, Kenneth, Skiba, and Matthias, Thimm, and it's called Distinguishability in Abstract Argumentation. So first of all, our work is very much motivated by and also related to the argumentation framework elicitation problem. And in that problem, we consider an agent who possesses an abstract argumentation framework, and our goal is to uncover or elicit that argumentation framework. More precisely, we aim to elicit the syntactical structure of that argumentation framework's attack relation by asking questions about its semantics. So we basically just ask questions in the form, is a set E of arguments a sigma extension of your argumentation framework, with sigma being a semantics? Now, the problem with that is that different argumentation frameworks, so argumentation frameworks with different attack relations, could still have the same extensions with respect to one or more semantics. So this makes this problem very challenging and maybe even impossible with only if we limit ourselves only to asking this type of question. So what we first do is we only aim to elicit argumentation frameworks sigma equivalence classes. So basically, instead of trying to find the one specific exact solution, we try to find a set of possible solutions which have the same sigma extensions. Also, in the scope of this problem, we refer to the type of an agent as a set X of semantics, where for each sigma and X, the agent truthfully answers whether a given set is a sigma extension of their argumentation framework. So what we basically did in our work is we examined the relationship between an agent's type and the equivalence class that we can discover. So now very quickly, just a couple of preliminaries, just so that we're all on the same page. I'm not going to formally define anything because there's just not enough time for that. But anyway, what we considered were classical Dung-style abstract argumentation frameworks, and also the more classical semantics, so conflict-free, admissible, complete, grounded, preferred, and stable semantics. Plus, we also looked at semi-stable semantics. So now, before I go ahead and formally define this distinguishability, I'm going to define what we used as equivalence. So two argumentation frameworks, F and F prime, are called X equivalent, with X being a set of semantics, if for all sigma and X, the sigma extensions of the two frameworks are the same. So we can also quickly look at an example of this. So here you can see these two argumentation frameworks, F1 and F1 prime. And it's also quite easy to see that they have the same conflict-free extensions, which are the sets containing only A, only B, and only C, and the empty set. And those two frameworks also have the same grounded extensions, which is same one grounded extension, which is the empty set. So we can conclude that F1 and F1 prime are conflict-free and grounded equivalent. By the way, they're also not equivalent with respect to any of the other semantics, but I'm not going into detail with this here. All right, so now we can finally define distinguishability. And we say that a set of semantics X distinguishes an individual semantic sigma in a given set of argumentation frameworks if for every pair F and F prime in that set, it holds that if F and F prime are X equivalent, it follows that they're also sigma equivalent. So in other words, what follows from this notion of distinguishability is that if we know the X extensions of an argumentation framework, then we basically also know the sigma extensions. So we can have a look at a rather trivial example for this. For example, the set containing only the complete semantics distinguishes the grounded semantics simply because the grounded extension is always the minimal complete one. So if we think back to what I just said, since we know all the complete extensions of an argumentation framework, we can also know the grounded extension. All right, so another example is this one, and this one's a negative example. So here again, we have two argumentation frameworks, F2 and F2 prime. And those two argumentation frameworks are conflict-free, admissible, preferred, stable, and semi-stable equivalent, but they're not grounded equivalent. And what follows from this is that neither conflict-free, this whole set of semantics nor any of its subsets can distinguish the grounded semantics. All right, I'm almost out of time, but I still want to show you what kind of results we got. So first of all, we have some positive results of the form X distinguishes sigma, with, well, X once again being a set of semantics and sigma being individual semantics. We also provided proofs for all of our positive results, so you can look at the paper for that. And we also, of course, have some negative results, and for those we provided counterexamples. Furthermore, we examined not only the set of all argumentation frameworks, but also some more restricted sets of frameworks, which are namely the set of all self-attack free, the set of all odd cycle free, and the set of all acyclic argumentation frameworks. And yeah, just here just two more specific examples of our results. So for example, in the set of self-attack free argumentation frameworks, we can see that if we know the conflict-free and preferred extensions, we can also know the stable or semi-stable extensions. And on the other hand, we can also, if we know both conflict-free and semi-stable extensions of framework, we can also know the stable extension. So that's it from my side. Thank you for your attention. I think my co-authors and I are happy to answer any questions.